Hi, my name is George Mormisato, and I'm going to demo GridWhale. The idea of GridWhale is to create a massive virtual computer made up of multiple machines all acting as one. Programs running on GridWhale are easy to write because they think they're running on a single machine with almost infinite resources. In reality, under the covers, they're running on a data center on a distributed set of machines. But we've built a grid abstraction layer, or GAL, that hides all that away. So let me show you some programs running on GridWhale. This is not the final product, of course, but it does have the core concepts and architectures, just enough to prove out the concept. And importantly, this is live. So if you want to try this out yourself, you can go to gridwhale.com, create an account, and try some of these things. I do caution you, this is still very, very early, so a lot of things will not work, and other things will just probably break. But if you'd like to try, please do so. Now let me show you some of the things you can do. Here I've signed into GridWhale. You can see I've got an account here on GridWhale. Every user will have an account, and under that account they can create any number of programs. If I go to my home directory, here I see a list of all the programs I've created. Again, this is kind of just placeholder UI, but it gives you an idea of what's going on. Let's do the simplest little program. One of these programs is obviously just Hello World. That's the simplest possible program in GridWhale. There's a language here that we use to write GridWhale programs. It's a very, very simple, more or less procedural, a little bit of object-oriented language based on Python, but with unique features that are special for GridWhale. I'm going to run this. And as you might expect, you can see right here, it just returns Hello World. Now, obviously, this is a trivial program, but what's going on under the covers, I think, is very interesting. This program is running on some data center fabric, on some service, and when it's executing, all the inputs and outputs get remoted directly to your browser, so that it feels as if you're just running the program directly. From the program's perspective, it thinks that it's just running on a single machine. From the user's perspective, you just think you're running the program on your local machine. So it's all the infrastructure to make that seamless and to make that work is kind of the magic of GridWhale and the grid abstraction layer. Let's show you why that's kind of an interesting concept and an interesting way of doing things. I'm going to show you a chat program. So this is a multi-user chat program, and I'm going to just kind of walk through a little bit to just show you how easy it is to create these kinds of programs on something like GridWhale. Now, if you were to try to create a chat program on a PC, obviously it'd be very difficult. You'd have to write all this network code. You'd have to do all this transmissions and coordinate between different machines. It'd be very, very hard. If you want to write it in kind of a modern web app way, again, it's not that easy. You'd kind of separate between front end and back end. You'd have to create this back end that's distributed over a large set of machines. You'd have some caching system to make sure that you can scale up to some number of users, et cetera, et cetera, et cetera, et cetera. It's not that simple. In GridWhale, though, because from the program's perspective, it's taking advantage of this grid abstraction layer, it's actually pretty easy. So here's how we do it. First of all, this relies on an abstraction called a data set. Right here, we're kind of creating a new data set of type data queue. And basically what this is a shared memory structure. Now, from the program's perspective, this is just a piece of shared memory that they can access and that other programs from other users can also access simultaneously. The GridWhale abstraction layer handles all the coordination, handles all the processing. In reality, of course, this could be on a totally different machine. The program could run on one machine, but be accessing the data set on a totally different machine. But that is all those details are worked out by GridWhale. This program doesn't have to worry about it. All we have to do is basically say, okay, just give me get that little chat log data queue. And the only other thing I do here is I register for an on change. So I say when this data log changes, I want to get called at this function. And what am I going to do? I'm just going to print out whatever it is that just changed. Super simple. And then the main loop, again, very, very trivial. I ask for input. I say type some stuff. As long as they haven't done quit, all I do is I push that, whatever they type, into the chat log, prepend the username. That's really, not a big deal. All right, so let's try this out. I'm just going to run it. And here I am. It's just asking for input. So the program is running on the GridWhale service, and when it sees a line called input, it basically just waits there for the client to type something. I can type in hello there. And when it goes all the way down to the service pushes it up into the data set, into that shared data structure, and then broadcast it out. We get the change, and it all kind of just I can just type whatever I want, even if I don't spell it correctly. Now let's show this off. We're going to do this on a different user. I've got a totally different browser here and a totally different user, and I'm just going to copy this URL here, because GridWhale programs, basically you can just go to different URLs. And here I am, I'm in the exact same chat session, but of course I'm signed in as a different user. And so, I can type, and then, over here I can type back. And then we can see, that all the text is working. So obviously this would work. I happen to be doing this on the same machine, but the service is on a totally different machine. If I were running this from Japan, we'd just all be able to rendezvous. And if there were hundreds of users, thousands of users all participating in the chat, it's up to the GridWhale system to deal with that scalability. Each of these programs is running, potentially could be running on a different node, on a different machine. So this chat program here could be running on a different machine from this one, and they'd all be coordinating and communicating together with this with the shared memory structure, and scaling that out and making sure that works correctly. That's all the responsibility of the GridWhale abstraction layer. So the program itself doesn't have to worry anything about that. That's why this program can be so simple. All right, well, let me show you some other stuff. Another good demo is, let's just show something with a little bit more complicated user interface. Here's a simple database system, which again uses some of the same principles. Here I've defined a schema for like a table record, right? So I've got a bunch of fields, I'm going to track asteroids, let's say. I've got name, mass, radius, distance, et cetera, it's just kind of standard stuff. And what I'm going to do here is, again, I'm going to do an open of a data set, and this is of type table instead of a queue. This is again a piece of shared memory, a shared structure. With various options, I could make this be a persistent piece of shared data, so it could get stored on some back-end table store, so that it can persist and have all sorts of redundancies. But for now, I'm just going to do it all in memory. I tell it the schema, and this is one of the advantages of GridWhale. The whole system is integrated, so the various pieces, the front end, the back end, the programming system, the business logic, all share these same programming concepts, and that makes it, again, very, very easy to program. So I basically tell this data structure, here's the schema that I want. I initialize it, here's some basic data, and then I add a couple user interface commands. Here's one to add a new asteroid, and that's it. I basically just say, okay, just run it. So let's run it. And here's my table. There's a set of standard controls, of built-in controls that programs can use within GridWhale. Table controls, button controls, text controls, that kind of stuff. And we just can create any number of interesting controls. And that handles the abstraction between the user interface and the program. So this way, again, the program can kind of deal with these abstract user interface concepts, and the client side, the browser, can figure out how to display it, figure out how to get events. All this is handled for you. So here I have a table. I can add some more asteroids. And notice, I just want to show you one thing. Notice, let me go backwards for a little bit. Once I define the schema, there's a single line over here where I basically say, bring up a dialog box with that schema and then get the results. And that's all I have to do in the program to generate that entire dialog box. So now from here, basically, this entire dialog box was generated by the underlying system. Again, the program doesn't have to worry about it. So this is, my new asteroid, some mass, some radius, whatever. And when I hit OK, it just gets entered. And same as with the chat program, I'm going to just demo. This is, of course, I'm just going to go in here. This is, of course, a shared data structure, and anyone has access to it. And I'll just give you some room here. And when I add one from here, I'm not doing any checking, but that's because the schema doesn't do anything. That you can see that it just automatically got added. So again, very trivially, I was able to create a program that lets you just store data in a table and share it, and the GridWhale system is in charge of scaling that out to however many users want to use it. So the final thing I want to show is a way now. I'm going to show you a Mandelbrot demo. The cool thing about GridWhale, again, is because we're running on this grid of large numbers of machines, we can both scale out by having any number of users share data across them, or we can also have a single program take advantage of multiple machines to do computation. So now it's easy for a single program to take advantage of however many machines it needs in order to do its computation. There's some limitations, some abstractions we have to do, obviously, but here we're going to demo it in Mandelbrot. The idea in here is pretty simple. We're just going to generate a Mandelbrot set, and this function here has been parallelized under the covers to kind of work on as many cores as necessary. And the GridWhale system provides a set of primitives that let you distribute things like that. So for instance, we provide a simple map function where you pass in a function that you want to execute, and that function can get executed on any number of machines, any number of cores. And all you have to do in order to parallelize that is basically just specify kind of in this options system, options parameter, the number of cores that you want to, maximum number of cores that you want to devote to this particular job, to this particular task. And so that's what this is doing. This happens to be some input. So we've got a dialog box here. I've defined a dialog box where I get to input, what we're going to do, and then one of those is the core. So let's do it. Let's see how this works. I'm going to run the program, and let me just start a Mandelbrot. And here we bring up a dialog box, and these are the coordinates of the Mandelbrot, the zoom, and all that. And here's the interesting part. This is where we get to control the number of cores to use. I'm going to start with just 4 cores, and you can see it's kind of done a Mandelbrot, and it did it in the whole time. Wall time is 0.188 seconds. But in terms of computes, because it used 4 cores, you add it all up, and it's a little bit more time. Let's do a bit of a bigger zoom, and you can see this will take a little bit longer because it's there's just more complexity here, and you can see how the compute time has kind of gone up. Now it's taking 2 seconds to do the whole thing across 4 cores. If I were to do this on a single core, then obviously it's going to take a lot longer. You can see now that it's only got 2 core. With only 1 core, it used up 2.5 seconds to do the whole thing. You could tell that it was slower. Here we can see a couple of things. We can see how many cores were used for this latest run, and also we see how many nodes were used. That's kind of saying the number of machines that we distributed this across. So let's do 8 cores now. And now it's going to exceed the number of cores on one particular machine, and it's going to try to distribute it over multiple machines. So now you can see that it's used 2 nodes and 8 cores across those 2 nodes. And you notice also that the time is a lot faster. It could do it in a very, very short amount of time. So let's see. I can even go even deeper. And again, the total time it used to compute goes up, but the actual time the user's waiting is a very small amount of time. So this is the kind of stuff that you can do with GridWhale. Again, from the program's perspective, you don't have to do anything special. All you have to do is just specify how many cores you want to use, and the underlying system figures out how to distribute that to however many machines it needs. You can specify 100 cores, 1,000 cores, whatever. It's just whatever you're willing to use, and GridWhale provides primitives for your programs to get distributed across that without you having to worry about it. So that's basically it. That's the kind of concept of GridWhale. This is, like I said, just a prototype. It's got all the architecture and a lot of the systems, but obviously there's a lot of work to do. There's a lot of refinement that needs to be done, and a lot of optimization. There's a lot of things that don't work, and a lot of things that we're planning to do with this. So if you're interested in helping, if you wanna use the system, go to gridwhale.com. You can kind of try it out and just do some simple things. In the archives folder, there's some documentation where you can look at, kind of describes the system a little bit. This is not 100% complete. There's probably a lot missing, but it's got a little bit enough to get you started, and you can see what GridWhale is all about. And if you're interested in helping out, please just contact us, and we'll love to hear feedback on this. What you think about it, what you might use it for, what kinds of additional features you'd like on it. Pretty much anything that you're interested in saying, we're interested in hearing. So so try it out and let me know what you think. All right, thanks.